Okay, we're looking at question 2. I'm going to take a read of it. Golic PLC is financed by 70% equity and 30% debt. So basically, this information is relating to Golic PLC's capital structure. Okay, remember, a company can be financed by equity or debt. So this company is being financed by 70% equity and 30% debt. The debt consists of a 10% bond with a 6 years to maturity issued at nominal value of 1,000. So this sentence here, which says 6 years to maturity, tells us the debt is redeemable, and it's redeemable in 6 years. The current market value of the bond is 1,031 per 1,000 kwacha. So, as it states here, this is the market price of the bond, which is 1,031, and this 1,000 here represents the book value. As you can see here, it says per. So whenever you see per, just remember that is the book value. Okay. The equity premium is 7%. All right. So equity premium, basically, this is the excess return earned by an investor when they invest in the stock market. Okay, so equity beta is represented by the risk-free, the market return minus the risk-free rate. Yes, the market return minus the risk-free rate. Where was I? Yes. The market return, this is basically the money you get back from investing in the stock market. And the risk-free rate, this is basically an investment that bears no risk. It just tells you you're going to get your money, and there's a certainty that you're going to get your money. And that's usually the case with government bonds, okay? Because government doesn't default on payments, so usually bond from government is risk free. Okay, and Golic PLC asset beta is 0.9. So the asset beta basically it compares the risk of an unlevered company to the risk of the market. So when you hear the word unlevered company, this is a company with no debt. So it's just comparing the risk of a company with no debt to the risk of the market. Now, whenever we're given our asset beta, we're supposed to find our equity beta. Okay, the equity beta is just a measure of the sensitivity of the share price of a company in relation to the stock market. All right, you just basically say how does the price of the share of the company change with changes in the market. When the price changes in the market, how does the share price respond to those changes in the market? All right. The 5-year government bond yield is 6%. So whenever you hear bond yield, just think of the risk-free rate, this 6%. Okay. Corporate tax is 30% per year. Calculate the weighted average cost of capital, Wacc, of the business. Okay, so we're going to start like this. Our value of equity and our value of debt, which are represented as this VE and VD, have already been given to us here. This 70% and this 30%. So the 70% is our VE. Okay, then our 30% is our VD. So we do not need to calculate the market values. But the first thing we're going to have to calculate is the cost of capital. Okay, So whenever you hear these terms like asset beta, equity premium, you have to know that you're going to calculate your cost of capital using the capital asset pricing model. The capital asset pricing model shows the risk in relationship to expected returns. Okay, the risk in the market, okay, in relationship to expected returns. Expected returns are also called cost of equity, so they're interchanged. So the CPM, the formula of the capital asset pricing model is KE equals RF plus our equity beta, and we open bracket, the market returns minus the risk-free rate. But we can see in our formula here, we haven't been given our equity beta. Okay, we have not been given our equity beta. So we have to find our equity beta using the relationship the equity beta has with the asset beta. So basically, whenever I hear the word beta, it's just the measure of market risk. Beta is measure of market risk. All right, so this is the relationship between the asset beta and the equity beta. We're going to okay, so say BA, which represents the asset beta, equals BE, which represents the equity beta, open brackets, the value of equity, which we've already been given as 70%, and over the value of equity again, plus the value of debt, and open brackets 1 minus T. All right, so we start replacing the values. Our asset beta that was given to us is 0.9. Okay, our equity beta just stays the same here. Okay, so that 70% we're given, we're going to say 70 divided by 100. Okay, since it's a percentage, so it's over 100. So 70 divided by 100, that gives us 0.7. Okay, so we're going to say 0.7 over, okay, again, our value of equity is found in our denominator here. We'll say 0.7 plus our value of debt, which is 0.3, open brackets, 1 minus our tax rate was given to us. Okay, the tax rate is 30%. Okay, so 30%, just divide that by 100, that gives us 0.3. Here. So we're going to start our calculation like this. We're going to say 1 minus 0.3, that gives us 0.7. Okay, let's get our calculators, guys. Give me the values. Let's give me the value and divide 0.7 over 0.7 plus 0.3 times this. Give me the value that you get. Yes.
It's gone.
No, I'm here. I'm waiting for the answer.
I got 1.21.
1.21 when you did the calculation in the brackets.
I got 1.21.
1.21. Okay. Our colleagues, what have we got? Okay, let's do it together. So say 1 minus 0.3, we get.
Our colleagues here were just the two of us.
Okay. So 0.3 times 0.7 and 3 times 0.7, we get 0.21 here. Okay, then 0.21 plus 0.7, we get 0.91. So our denominator here becomes 0.91. Okay, then 0.7 divided by 0.91, we get 0.7692.
Mhm.
0.7692. So how did you said you got what at first?
One point two one. Let's come and get it.
Okay.
0.7
Yeah.
divided by what?
We're going to start with the one in the brackets first. The one in the brackets. 0.3 times 0.7,
Mhm.
that you get 0.21, right? You get 0.2.
Then when it's breaking, can you come and get it?
I said 0.3. 0.3 times 0.7.
Where are you getting the 0.21?
I've multiplied.
Which figures?
I'm multiplying this 0.3 times what's in this bracket here. One, this one here. Yes. Have you got 0 point thing? 21?
Yes.
Then plus 0.7. So then the 0.21 plus 0.7. You get 0.91.
Yes.
And then we say 0.7 divided by 0.91.
And then
0.7 divided by 0.91. What do you get?
0.7692.
That's our value here. So we're going to say BE.
Okay, understood.
All right, so we're going to say 0.7. We divide both sides by 0.7692. So what answer do you get? What answer do you get when you divide these two? Mr. James, you're quiet. What answer do you get when you divide 0.9 divided by 0.7692?
1.170.
Yes, so our equity beta equals 1.17. Any questions so far? Just remember, if you're given an asset beta, okay, you first have to find your equity beta using this relationship. Okay, and remember, a beta is just the measure of market risk. That's all. Okay. All right. So we found our or any questions before we move further. This is our equity beta, BE. Okay, we are clear there. All right, so we're going to now go back to our formula using the capital asset pricing model. Okay, it says KE equals RF, risk-free rate, plus BE, which is our equity beta, open brackets, RM minus RF. So this RM minus RF, this represents our equity premium. Okay, equity premium. Okay, this is the excess you get for investing in the market. Equity premium. All right, so now we're going to put in our values. Our risk-free rate was 6%. Okay, 6%. All right, let me refer to the question where I'm getting the 6%. This bond yield is 6%. So we'll take this as our risk-free rate. Okay, that's 6% plus our equity beta is 1.12. Okay, then our equity premium is 7%. So we can type in the calculators. Can we type in? Can we type in?
Because it's not 1.17.
Oh, Thank you, 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 thank
I've gotten 14.19.
you. 14.19, wonderful, 14.19%. So this is our cost of capital, 14.19%. Any questions so far? Okay, we are all good. Okay, so now the next thing we're going to do, because here we've calculated our cost of equity.
No questions.
Okay. We've calculated our cost of equity. Now we're going to calculate our cost of debt. So remember, this debt is redeemable. Okay, it's redeemable. So to calculate the cost of debt, we're going to use the internal rate of return. Okay, we're going to use the internal rate of return. Okay, so the formula is KD equals 8% plus the net present value, okay, at 8%, net present value when we're using 8%, over the net present value, okay, for 8% minus the net present value for B%. Okay, open brackets, B% minus A%. Okay, so this 8%, okay, 8% represents the lower discount rate. Okay, the lower discount rate, and this B% represents the higher discount rate. Okay, so these discount rates, all right, we're going to calculate the net present value here when we're using the internal rate of return, right? So now, when you're calculating the net present value, you're going to have a negative and a positive value. You're going to need two values. So you're going to use a high discount rate and a low discount rate. Okay, in calculating this. So I'm going to show you how we're going to calculate our net present values. Okay, so we're going to have to make a table. Okay, here we're going to say year. Okay, Next, going to say narration. Okay, then we're going to have cash flows. Okay, then we're now going to have first our first discount factor. Okay, we're going to have our first discount factor. Okay, so our discount factor, we're going to use this 10%, this interest rate for the bond. We use this 10% as our discount factor. Okay, I'll put it in abbreviations. DF. We're going to say add, okay, add 10%. And we're going to put here our present value. Okay, then again, we're going to have another column for the discount factor here. But this discount factor in this second column, this one, is going to be dependent on if this present value is negative or positive. Okay, if this present value that we get is negative, we're going to have to divide our discount factor by 2. Okay, if this our first present value, if it's negative, we're going to have to divide our discount factor by 2. But if the present value we find is positive, we're going to multiply this discount factor by 2. Okay, right. So we're going to start with year 0. Okay, year 0. We're going to put in here, we're going to put the market debt price. Market debt price. So we go to our question, what's the market debt price? Okay, so the current market value of the bond is 1031. Okay, so say 1031. So we're going to put this in brackets, which says that this is negative. Why is it negative? Because it represents an investment. So it's an outflow of cash. Okay, this is an outflow of cash. All right. So now the discount factor, to find our discount factor, all right, we're going to use this formula. Let me just write it on the side. 1 plus r to the power negative t. Okay. So our r in this case is going to be 10%. So you're going to say 1 plus 10% is 0.1. Okay. Then you're going to say to the power -0. So in your calculators, punch in this and tell me what you get.
I missed that. What are we punching?
1 plus 0.1 to the power -0. I'm finding the discount factor for year 0.
Plus. Plus 1 to the power -0. Plus 0.1.
Okay, this one, just know your answer will come out as 1. Okay, your answer will come out as 1.
1.
Always. Why? Because we have the power -0. Okay, if you remember in high school indices, anything to the power 0 equals 1. Okay, anything to the power 0 equals 1.
1.
Yes. So our present value, we're going to say 1031 times 1. Okay. Actually, -1031 times 1. Remember, it's in brackets, so it's negative. We get 1031 negative. Right? So the debt says it's got 6 years to maturity, right? So we're going to put from year 1 to 6, right? And this is going to represent the interest payment, right? The interest payment. Interest payment. So now to get our interest payment, okay, let me just make it on the other side. It's interest payment equals interest payment equals the after after tax interest rate. Okay, after tax interest rate. Okay, after tax interest rate multiplied by the face value or the par value of the bond. Face value or the par value of the bond. So to get our after-tax interest rate, we're going to say, remember our corporate tax is 30%. So we're going to say, we're going to find 10%, and we're going to open brackets, 1 minus 0.3. Okay, this 0.3 represents the corporate tax. Okay, so 10% is just the same as saying 10 over 100. So we're going to say 10 over 100. All right, 10 over 100 times 1 minus 0.3. Then we're going to multiply it by the face value of the bond. Okay, and the face value, okay, the nominal here says the nominal value, okay, is 1,000 here. Okay, can we punch in our calculators? Hey, that's you, Tamara and Mr. James. Okay. Tamara, you can punch in. One minus 0.3. Remember, order of operations, brackets first.
Okay.
Then multiply that by 10 and then divide it by 100. You found what?
I got 70.
70. Wonderful. Wonderful. Wonderful.
76.
Yes, yes, wonderful. So I'm going to put our 70 here. Okay. So now this 1 to 6, it's representing repeated payments, okay, what we call annuities. All right, this is an amount that doesn't change and is paid at a fixed period of time. An example of an annuity can also be your rent, right? For a certain year, you'll be paying the same amount each, and for a fixed period, each month you're paying the same amount, paying the same amount, payment, same amount. So that is an annuity. Okay, an annuity. So now the formula, right, to get an annuity, okay, the formula to get an annuity is 1 minus, open brackets, 1 plus R, okay, which is the discount factor, to the power negative T power negative T divided by R. Okay, So this is the formula we're going to input to find our discount factor for the 1 to 6 years. All right. So in your calculators, you're going to say 1 minus 1 plus our discount factor is 10%, remember. So we'll say 0.1. Then you're going to say to the power negative 6. All right. Since it matures in 6 years, so that's the final year, 6. Then you're going to divide it by 0.1, okay, which is the 10%, which we're using as our discount factor. Okay, so punch this in your calculators. Excuse me. So remember, order of operations, board mass. First, you start in the parentheses, okay. Actually, it's now called paid mass. Paid mass, parentheses, then exponents. So when you find this, you find it to the power negative 6. This is our exponent, okay. First add this, then find it to the power negative 6, then subtract from 1 and divide by 0.1. So how to tell a payment is an annuity? It is repeated, okay? It's repeated. It's a repeated payment. So that 1 to 6 represents a repeated payment. So what value are we finding here? So the value we find here, we're going to put it here. The 1 minus. No one has found any value yet. Okay. Okay. Tamara. Okay, 1. Let me calculate then. Okay, so 1.1 to the power negative 6 is 0.56444. Okay, the other numbers, but I'll just end there, 0.56444. Right, so we're going to say 1 minus 0.5644. We're going to get 0.4356. All right, we're going to get 0.4356. Then we're going to divide that by 0.1, and we're going to get 4.356. All right. So now we're going to multiply this 70 by 70 times 4.356. Right, we're going to multiply it. We're going to get 304.92. Okay. Then we're going to put again here year 6, and then we're going to put power value or face value. Okay, which is 1000. Okay, so now we'll go again to this, to get the discount factor. We're going to again say 1 plus r to the power negative t. Okay, so in this case now it's going to be 1 plus 0.1 to the power negative 6. All right. In this first column, we used this one here. It was to the power negative 0. And now here is going to be to the power negative 6. So I'm going to say 1.1 to the power negative 6. That gives us 0.564. Okay, so we're going to say 1000 times 0.564, that's going to give us 564. Okay, so this 1000 here in 6 years is going to be equivalent to 564. Okay, so now what we're going to do next is we're going to total up our present values. Okay, we're going to total up our present values. Okay, so we're going to start. We're going to say negative 1031. Let's get my calculator. All right, so we're going to say negative 1031 plus 304.92 plus 564. Okay, and we're going to get negative 162.08. So our present value is a negative value, all right? So whenever our present value is a negative value, our discount factor, which is in this next column, all right, we're going to obtain it by dividing the first discount factor we had, all right, this 10%. We're going to divide it by 2, okay? If this present value was positive, okay, if this was positive, we would have multiplied it by, would have multiplied this 10% by 2. But since it's negative, we're going to divide this 10% by 2. So 10 divided by 2, that's 5%. Okay, so now our discount factor is going to be 5%. Okay, so we're going to repeat the process again. All right, so we'll say the discount factor for year 0. All right, we're still using this same formula here. 1 plus r equals 1 plus r to the power negative t. Okay, now in this case, our r is going to be 0.05. Okay, this 5% you divide it by 100. Okay, it's 5% divided by 100, so you're going to get 0.05. You just have to squeeze it there. So we're going to say 1 plus 0.05, and then we'll say to the power negative 0. Okay, that's for this column here. Okay, and as I said again, anything to the power 0 is 1, so you're still going to get 1 here. All right, okay. Then now we go to our discount factor for the interest payment. All right, since this is an annuity, all right, we're still going to use the annuity formula, but in this case, this won't have 0.1 here. We're going to have 0.05. So we're going to say 1 minus 1 plus 0.05 to the power negative 6. Okay, power negative 6 divided by 0.05. Okay, so let me do the calculation. Tamara stopped helping me with the calculations. So say 1 plus 0.05, that's 1.05, and say to the power negative 6, we're going to get 0.7462. Okay, 1.05 to the power negative 6 gives us 0.7462. So now we're going to say 1 minus 0.7462. We're going to get 0.2538. Once again, 0.2538 divided by 0.05. Hold on. Let's stop. 0.2358. That was the number I shouted out, huh? 0.2358 divided by 0.05 Was that the value I shouted out, the 0.2358? I've forgotten the value, so I don't start the calculation again. 1.05 to the power negative 6. Just write down the value so I can forget. Okay, 0.7. Okay. 1 minus 0.74. 0.2538. And the value bar 0.0. Right, we're going to get 5.076. Okay, 5.076. All right. Then we're going to go now to the year for our face value. All right, we're going to say 1 plus 0.05. 1 plus 0.05 to the power negative 6. Okay, 1 point. We're going to get 0.746. 0.74746. Any questions? Any questions? Okay, wonderful, wonderful. All right, so I'll try to be as neat as possible. So again, we're going to say 1031 times 1 we'll get, because we're now calculating the present values. 1031 times 1 is 1031. Okay, then we're going to say 304.92 times 5.076. So we're going to say 304.92 times 5.076, and we're going to get 8. I'm going to put the figures properly. So 304.92 times 5.076. We're going to get 1,547. 1,547. One five four seven. Right. Then we're going to say 564 times 0.746. 564.
I see 420.744.
Say it again.
Four two 0.744.
Okay. 0.7444. Okay, so now you're going to add all the present values. When it's a negative 1031 plus 1547 plus 420.77. Oh, just hold on one bit. Sorry, I made a mistake. It's the cash flows which are going to be multiplying by your discount factors, because the present value is cash flow times discount factor. So we're not going to multiply present and discount factors here. No, we're going to say these cash flows are going to multiply them by their discount factors. Sorry about that. Yeah. So to get your present value, it's cash flow times discount factor. So here I'm going to say the cash flow was 1000 times 1. We still have this. We still have 1031. Okay. Then it's supposed to be 70 times 5.076. Okay. 70 times 5.076. Okay, you're supposed to get 355.32. 355.32. 355.32. Then you say 1000. Okay, our cash flow 1000 times our discount factor of 0.746, we get 746. 746. Okay, then now we can do our calculation now. It's 1031 negative 1031 plus 355.32 plus 746, and we're going to get 70.32. So now we've got a positive net present value, 70.32. 70.32. Right. So yeah, to get your present values, it's cash flow times discount factor. Okay. So yeah, we found now a positive net present value. So now what's going to happen is these present values and these two discount factors, 10% and 5%. Okay, 10% is the higher discount factor, okay, which is the B percent. that formula was the higher discount rate. Then our A% is going to be this 5%, which is the lower discount factor. Okay, so then our NPV, when it says NPV B%, all right, is going to be represented by this 162.08 NPV B%. Okay, then our NPV A% is going to be represented by NPV, which is just the net present value. NPV A% is going to be this 70.32. Okay, so B%, the higher discount rate, NPV B%, this this present value found here, and our A%, which is the lower discount rate. So we'll go to the formula again for the internal rate of return. Where did I put it? Here. Okay, and we're going to substitute now. Okay, so our A% is 5%, the lower discount rate, plus the net present value for A% was 70.32, 70.32 divided by, so again, it says 70.32 minus NPV B% is, what is that? What's our NPV B%? Negative 162. What value? Negative 162 point. Let me just check the value. Negative 162.08. Remember, it's negative because it's still in brackets. Point negative 162.08. Okay, then we're going to open bracket. We're going to close the brackets here. And B% minus A%. So B% is negative. Oh, this B% is the 10% for the discount rate. 10% minus 5%. Okay, this is the higher discount rate, lower discount rate. Okay, so we get our calculators and we start punching in. 10 minus 5, that's 5. Okay. 70.32 minus negative 162.08 gives us 232.4. Okay, so here we get 232.4. Okay, then we're going to say 70.32 divided by 232.4, you get 0.302. Okay, when we divide this, we're supposed to get 0.302. Okay, so this 0.302, we're going to multiply it by 5. We're going to get 1.51. Okay, 1.51. 1.512. So after we've done all these calculations here, we're supposed to get 1.512. One point, oops, 1.512. And then we're going to add it with 5, this 5%, okay, which is going to give us 6.51%. 6.5, oops, 6.51%. Okay, questions? 6.51%. So that is our cost of debt. Are we safe? Are we safe? So finally, now we have to calculate our weighted average cost of capital. Okay, so we get our Wacc formula. We say Wacc equals, right, value of equity over value of equity plus debt. Okay, so this denominator just represents the total value of the capital structure, which is equity and debt, and then we're just getting a proportion of the equity. We're saying what proportion of equity, okay, is used to finance the company's projects. Okay, then we're going to multiply this by the cost of equity plus, okay, now we're getting the proportion of debt out of the total proportion of the capital structure, which is equity and debt. And so say VE plus VD KD 1 minus T. All right, so we just substitute our values. Our value of equity was 0.7. Okay. Our value of debt was 0.3. Okay, so 0.7 plus 0.3, that's 1. So the total value is 1. So we're going to put both of these over 1. Okay, our cost of equity. Okay, our cost of equity, what did you find as our cost of equity? Found 14, right? If I recall, found 14. Times 14% plus the cost of debt, which we found was 6.5%, times 6.5. Okay, so 0.7, 0.7 times 14 is 9.8 plus 0.3 times 6.5, that's 1.95, 1.95. So 1.95 plus 9.8, we're going to get 11.75. Okay, 11.75, we can round it off to 12%. So that's our weighted average cost of capital. Questions? Hello.